Okay, so we're going to talk about rules of exponents. Okay, and the first rule that we are going to look at is what's going to be called your product rule. Okay, the product rule for exponents. So when dealing with exponents, we're going to have a little bit of vocabulary we got to talk about. You're going to have like x to some power. We're going to say the a power times x to another power, so another number up here. So you have x to the a times x to the b. Now, these things right here, the x's that are raised to a power, these are going to be called our base. And then the a and the b are our exponent. And there is a multiplication sign in between them. So you have a base of x, you have an exponent of a, and a multiplication sign in between them. Okay, that goes with the product. Product means to multiply. So our product rule is going to be when we're multiplying the same base. Okay, the product rule states that if we have x to the a times x to the b, we keep the base x and we add the exponents. So the answer will be x to the a plus b. That will be our answer for the problem. Okay, so how does that look? How does that look in terms of what I'm going to be asking you to do? So let's look at a couple examples of the product rule. Let's say we have x to the third times x to the fifth. Okay, well, I have the same base. I have the same base of x. I am multiplying in between. What I'm going to do is I'm going to add the exponents together. So we're going to have x to the 3 plus 5, which is x to the 8th power. And that one's done. That's how you would apply the product rule to that problem. Okay? Now, what happens if we have some numbers or some coefficients in front of the x? So say we have like a negative 2 x to the fifth times 10 x to the second. Okay, well, you can still multiply numbers. You can still multiply these coefficients by each other. We can still say negative 2 times 10, and negative 2 times 10 is still negative 20, hasn't ever changed. Okay, and then we have to deal with the exponent part. So the bases of our exponents are the same here. I have a base of x. So I'm multiplying these between my bases so I can add the exponents. So I can say that this is going to be x to the 5 plus 2, which is x to the 7th power. And so that's really all the product rule is telling me to do, is to look for that same base, add those exponents together. Let's look at one more. So let's see if I have two different bases in there with exponents. So maybe an x and a y, or maybe an a and a b. So let's say we have 3 x to the third, y to the second, times 4 x to the second, y to the 10th. So again, the coefficients, the 3 and the 4, we're still multiplying these together. So 3 times 4 is going to give us a coefficient of 12. All right, and then we've got to go look at the bases for the exponents. I have a base of x and a base of x here. So I'm going to add my exponents together with that same base. So that's going to be x to the 3 plus 2 power. So x to the 5th power. And then I have another base. I have a base of y right here. So I have y to the second times y to the 10th. 2 plus 10 is going to give me y to the 12th. So there, the product rule with some different bases, that's how that one is going to work together. Okay, so that is our product rule. So the key on the product rule, multiplication between the bases, add the exponents together. Okay, that is our product rule. Now we're going to talk about our second rule, and that's going to be our power rule. Okay, so the power rule. And the power rule is going to take place when we raise an exponent to another exponent. So the power rule, if we have x to the a, and that's raised to the b power, then what we're going to do is we're going to multiply these exponents together. This is going to be x to the a times b power. Okay? Whatever the number that is, that's going to be the number that goes with that. Okay, so where does the power rule come from? The power rule actually comes from the product rule. It's just a shorter way to do the product rule. So if we look at our first example here for our power rule, let's say we have x to the third, and it's raised to the fifth power. Okay, so there, in this case, my a is equal to 3, and the b is equal to 5. So I have a is equal to 3, and the b is equal to 5. Well, this answer is going to end up being x to the 3 times 5, which is x to the 15th. Okay, but I'm going to show us kind of where all that comes from and how we use the previous rule, the product rule, to come up with the power rule. So we're not going to have to do this every single time, but this is where the rule comes from. So we got to talk about, what an exponent means. So that 5 right there means that my parentheses is going to be written out 5 different times. 2, 3, 4, 5. Because exponents are just repeated multiplication. So that is x to the third times x to the third times x to the third times x to the third. And we're doing that a total of 5 times. Okay. Again, the symbol between these parentheses it's like having a dot between them, like we did earlier. So this is like multiplying the same base together. And so we have 3 plus 3 plus 3 plus 3 plus 3. Well, 3 plus 3 5 times is the same thing as saying 3 times 5. Okay? So the power rule, when you have a power raised to another power, instead of writing all this out, because as this number gets large, we don't really want to write out this whole strand of numbers. We would rather just skip to the solution. So this is going to always behave this way. And so this is going to give us x to the 15th power. So we can apply that power rule and say this is x to the 3 times 5, which is x to the 15th. Okay? So that is where the power rule comes from. So let's look at a case with our power rule that might be a little bit more involved. So let's say we have another number inside, a coefficient, right? Let's say the coefficient is 3. And let's do b to the 4th power. And this is all raised to the 3rd power. Okay? Now, the exponent here is 4 on the b. It's not listed with the 3. But I want you to always remember that every number has an exponent. So there is an understood number that goes right here with the 3, even though it's not listed. And that understood number is 1. So this is like 3 to the 1st times b to the 4th. All of that raised to the 3rd power. Okay? So if we apply our power rule, this power gets multiplied into both of the exponents. So it's going into the 3 and it's going into the 4. It's kind of like the distributive property, all right, with the exponents. So you're going to get 3 to the 1 times 3, which is 3 to the 3rd power. And then b to the 4 times 3, which is the 12th power. Okay, and we can leave our answer like this. Sometimes on a multiple choice test, you might see where they have worked out 3 to the third power, because you can multiply 3 times 3 times 3, right? 3 times 3 is 9, 9 times 3 is 27. So you might see it listed like this, or they might go ahead and multiply those out and have the whole number 27 in front of the b to the 12. So that's 2 cases with our power rule. Okay, so that exponent on the outside of the parentheses gets distributed in to all of the exponents on the inside of the parentheses. Even those exponents, even those that are a 1. Okay, and even if this was a fraction and you had numbers in the bottom of your fraction, all right, this would get distributed to those as well. Okay, let's look at now our next rule, which is the quotient rule. So the product rule was when we were multiplying in between the same base, and the quotient rule is going to be where we divide the same base. So the quotient rule states that if we have x to the a power and x to the b power, okay, we are dividing these bases. So I have x to the a divided by x to the b. The quotient rule tells us that we are going to subtract the exponents. So we're going to subtract those exponents. Just like on the power rule, when we were multiplying between the same base, we added the exponents. The opposite of multiplication is division. Okay, here's our division sign. So the opposite of adding the exponents is subtracting the exponents. So it's very logical course of action here. So we're going to have x to the a minus b. Okay, would be really where we're headed with this. Now, because you might get a negative number when you do this, when I first teach this, I always tell you to look for the side of the fraction, or either the denominator or the numerator. So numerator on top, denominator on bottom. Which one has more? And if one of them has more, start your subtraction with that number and then leave the exponent where there is more. Okay, and I'll show you what I mean by that because we haven't talked about negative exponents just yet. So here's an example. Okay, here's how our quotient rule will work together. Let's say we have x to the third over x to the seventh. Okay, x to the third over x to the seventh. And this is going to prove that point that I was just talking about. Okay, so we're going to subtract our exponents, right? We're going to subtract those. But I would like to start with whatever has more. Which one is more, 7 or 3? It's going to be the 7, right? So 7 is bigger than the 3. So we're going to start with that. We're going to say, kind of over here in our little thought cloud, all right, 7 minus 3 is 4, right? So we're going to have x to the fourth, but our answer, because this 7 is in the bottom of our fraction, we're going to have more x's remaining in the bottom of our fraction. So this answer is going to be 1 over x to the fourth. And I'm going to show you where that 1 comes from. Again, I'm going to show you the long version where the quotient rule, why the quotient rule makes sense, and it makes sense to subtract exponents. So let's go back, and I'm going to show you how we're getting to this. So let's think about x to the third is really x times x times x. 3 x's being multiplied together. And x to the seventh is going to be 7 x's being multiplied together. Okay, I've got 7, I think. 1, 2, 3, 4, 5, 6, 7. Okay, now you're going to have some things in this that are going to cancel each other out. So x over x will cancel. This x over x will cancel. And another x over x will cancel. Okay? Well, just like 2 over 2 is equal to 1, and 3 over 3 is equal to 1, x over x is going to equal 1. Right? Doesn't matter what you put in for the x. It's going to always cancel out and be a 1. So that's where our 1 comes from in the top, because there's nothing left up here except the 1. Okay? And then look what's left in the bottom. We have x times x times x times x, and that's listed 4 times. Okay, well, the easier way to write that is just x to the 4th. And so instead of, like we said, instead of writing out all of this every single time we have a quotient rule problem, we notice that, hey, some things cancel out. That's just like subtracting the exponents away, and we're left with the ones left over, right? And the ones left over is going to be the one that has the bigger amount or the larger number as the exponent. Okay? So, let's look at another one. Right? Let's look at one with some coefficients. So maybe 14 x to the 10th over 7x to the 2nd. Okay, again, I can divide numbers. I can divide coefficients. So I have 14 divided by 7. 14 divided by 7 is just 2. So our answer is going to be 2. Okay, you could put 2 over 1 if you wanted to, but it's not necessary to put that 1. And then now I've got to look at my bases. So I have a base of x. 1 is x to the 10th. The denominator is x to the 2nd. There's going to be 10 x's up here in the top listed out. There's going to be 2 x's in the bottom listed out. 2 of those 10 are going to cancel. Okay? And there's only going to be a 1 left in the bottom of our fraction. 2 of the 10 are going to cancel in the top. And there's going to be 8 x's total left in the top. Okay? Now, we don't have to put this over 1. You could. But you could leave this answer as 2x to the 8th. Because 10 minus 2 is 8. And 14 divided by 7 is 2. Okay? So that is a pretty good overall review of our quotient rule. All right, let's move lastly to the last rule that we're going to talk about, and that rule deals with negative exponents. So we're going to look at the negative exponents and how these work. Okay? So the negative exponent rule tells us that if we have x to the negative a, right, x to the negative a, then our answer is going to be 1 over x to the positive a. So the negative exponent flips in a fraction. Okay, if it's in the top of our fraction like it is right now, x to the negative a over 1, it's going to flip to the bottom. It could be like this, guys. You could have a negative exponent in the bottom of a fraction. If that was the case, you would flip the exponent up to the top. So this would just be x to the positive a in the top of your fraction. Okay, and the reason why this works that way really has to do with a pattern. So our pattern, we're going to look at a base of 2 and the exponents with 2. So I'm going to just write out 2 to the third, 2 times 2 times 2. If you do 2 times 2 is 4 times another 2, you get 8. Okay? And 2 to the second power. So I'm lowering my exponent by 1 every time. 2 to the second power, 2 times 2 is 4. My next one is just 2 to the first. Well, 2 to the first is just 2, right? And now we have 2 to the 0 and 2 to the negative 1. Okay? Well, the pattern that we see start to emerge is going to also teach us a rule about zero exponents, which we haven't talked about just yet, but I need to talk about that. So our pattern is we're dividing by 2 every time. So every time we make a jump down one exponent, you're dividing by 2. Okay? If I had done 2 to the 4th power, that would be 16. And that fits our pattern, right? 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 1. So if we hold with that same pattern, 2 divided by 2 is going to tell me what 2 to the 0 power is right here. And 2 divided by 2 is 1. Okay, and anything, that leads us to our rule, anything that is a 0 exponent is going to equal 1. So it doesn't matter what it is, anything. It could be a whole bunch of variables, letters in parentheses. If it's raised to the 0 power on the outside of that parentheses, that whole parentheses is still going to equal 1 because it's raised to the 0 power. Now, we've got to move into the negative exponent range now. So 2 to the negative 1. Well, if we follow this same pattern, it should be the same thing as 1 divided by 2. And 1 divided by 2, if we write that out, that's 1/2. Okay? Or another way to write that is 1 over 2 to the first. And here you see the rule, right? Negative a is the same as negative 1. 1 over 2 to the positive 1. 1 over x to the positive a. That's where our rule comes from. If you divide 1/2 into 2, you get 1/4. So 2 to the negative 2 is the same as 1/4. And we saw up here that 4 is the same thing as 2 to the second. So you could actually say this is 1 over 2 to the second. And again, you see here how those two are related to the negative exponent rule. Okay? So how would that look in a problem? I'm going to jump to a more complicated problem for this one and only do one example for the negative exponents. So let's say we have, let's say it's 3 x to the 10th over x to the second. And this is raised to the negative 2 power. Okay, so a whole parentheses could be raised to the negative 2 power. All right. Well, we're actually going to use previous rules to help us out to get this into something that's workable for us to solve. So we're going to distribute this negative 2n to all of the exponents. Remember that 3 has an exponent of 1. Okay? So when I distribute this in, you get 3 to the negative 2, x to the negative 20, over x to the negative 4. Okay? So right here, everything has a negative exponent. All right? So everything that has a negative exponent has got to flip in the fraction. It has to swap places in our fraction because that's what our rule tells us. Okay, that's what the pattern we saw. That's how it's going to work every single time. So we're still going to have a fraction, but this x to the 4th in the bottom is going to move to the top and become positive. The 3 to the negative 2 in the top is going to move to the bottom and become positive. And lastly, the x to the negative 20 is going to become x to the 20th in the bottom of your fraction. Okay? That took care of all the negative exponents. But most of the time, by the time we make it to problems with negative exponents, it's going to have some more steps. Like you saw, it applied the power rule to get this step. Okay? And when we're at this step, in order to simplify, I see a quotient rule. I see the same base, and they're divided by each other, right? So we're going to start with this denominator because it has more exponents. It has 20. We're going to apply that quotient rule. The quotient rule tells us to subtract the exponents, okay? And so 20 minus 4 is 16. Those are going to still be in the denominator of our fraction. So this is going to be 1 over 3 squared x to the 16. Okay, and you could say 9 instead of 3 squared. It's